defined in order to make the code safe and workable. Yeah, with that said, I'll do my just normal caveat. If all things go well with the audits in January, we are looking to try to start actually launching our vault strategy in January. So that means that we would be taking deposits, pre-deposits for a week to 2 weeks near the end of January. That's a target right now, if everything goes well with audits. And then with those initial funds, we would actually be using, so we're going to actually take those assets and deposit them into one of Gauntlet's vaults. We have a good connection with Gauntlet. Robot Ventures was one of our investors in 2 different rounds. And so those funds would basically be earning yield in Gauntlet's vaults and then we would deploy the protocol within a week or two. And then once we deploy the protocol, we'd be taking those deposits and putting them into structured positions within the protocol where it's basically a delta neutral market making position. And then we're also hedging the impermanent loss using options. And so I've been doing a lot of work with LPs to basically structure a deal that we think is attractive. That will start getting pushed out through a number of venues. Some of the venues being our distribution channels that we have through our investors, like DLEX. We'll push the deal out to their community. CPOX is another kind of group of whales, I would say, big wallets that they'll push the deal out through their community. And then there's some other ones that we're still negotiating with that might come after if we still have room. And then, yeah, so it's all coming together. I've been working on the engineering side, the legal side, the BD side, getting all these things together. And yeah, it's getting really exciting because we're really there. I'll pause there. I do have an engineering update, but I want to give a chance to not hear my own voice and hear from some of the other people in the team. Just that's the high level update. The rest of these updates are really engineered focused. So it's what the engineers contributed in the last week and a half. We were having an abbreviated sprint because of the holidays. And yeah, so each engineer will share that. It is a little bit more on the technical side. So appreciate everyone for listening in. And if you're not as technical, if you guys have questions, just pass them, just drop them in the chat at any time. We'll be scanning those questions and responding to them. Definitely would appreciate any questions, but hopefully we're actually like getting questions about engineering if possible. With that said, does anybody want to go first? I usually pick on somebody, but
I can go. My stuff is a little less technical this sprint. Basically, we are trying to integrate vaults into our front end, and that kind of involved picking a vault infrastructure provider that helps us create those vaults. So let me see. Okay, I'm sharing my screen. So yeah, so we had this spike created here to just understand the landscape, who are all of the vault infrastructure providers out there, and their differences, digging into their architecture and figuring out the right partner to work with to create this vault for us. And some of the protocols or info providers we looked at are Lagoon Finance, Upshift Finance, which is really August protocol, and then Veda, and then Era. Not really sure how to pronounce their name, but they are from Gauntlet. Without going into too much detail on each one, because that part gets a little bit more technical, we've so far initially picked Lagoon. The reason being they are, compared to the other one, the only permissionless vault infrastructure provider, meaning we can do everything in-house, create the vault, and then pick the strategies that we're going to run inside the vault, and then integrating it to our front end. Whereas some of the other vault infrastructure providers, we require them to work with us in a B2B manner. But also, technically speaking, Lagoon also has some very interesting architectural decisions that kind of fit our need. They are using the ERC 7540 protocol rather than 4626. So this means that when we are doing the deposits and withdrawals, it's an async action. It gives us a lot of flexibility in managing deposits and running our strategies the right way. Security wise, they are pretty well structured too. And this is their overall, this is from their website, how it's, and then this is my breakdown, just in our case, how we are going to use them. And like I said, security wise, we are able to use a safe to manage the vault, and then we can add different types of modifiers on top of the safe to limit the actions that the safe would be able to take regarding the funds in the vault, meaning whitelist protocols or whitelist certain functions that can be called within those protocols. And right now, what I'm working on is actually just deploying some vaults. We've deployed two vaults, one on Arbitrum and Sonic. These are kind of test vaults for us to figure out the flow of how they run things, and then making sure we got the kind of vault operation side handled. And then we are going to try to start integrating the front end with their vault. And this part is pretty well documented from their side as well. They have a lot of good documentation. So this is what we'll be working on when January rolls around. And pretty exciting stuff that Nin and I are working on. And I think Nin already shared some of the front end UI before, but anyway, he's helping us design that and put that together. And I'm trying to figure out the back end side of things and how they will be integrated. That's pretty much it from me. Let me know if there are any questions. But if not, I will popcorn to Nin.
All right. Thanks, Johan. Let me just share my screen. Just 1 second. Entire screen. Okay. Cool. All right. The last sprint or last week or so, I was mainly working on updating our LTV logic on our DApp. Like earlier on our DApp or on our front end, we were having the LTV calculations based on like this chart basically. So what LTV, like how do we calculate LTV is basically having total debt divided by total deposits. So what we were doing we were calculating all the borrows or like all the debts of individual tokens onto liquidities or the liquidity positions, and we were converting them in terms of the X values and doing the math. I noticed there were some changes compared to how the way we were doing on our contract, on our core contracts. On our core contracts, we are doing a little different. Basically, obviously, like I said, like the TV is debt by collateral, and but debts are the net values in terms of liquidity, right? It's representing the value of liquidity. So we are converting all of them to the liquidity tokens and then calculating the entire LTV. So this was a change which I worked on understanding and implementing on the front end logic and the front end library. Of course, I took help with Ishwar to dissect this and try to understand what's going on in all of them. Even on our front end validation library, this was our logic what we had earlier, where we calculate the net liquidity in terms of X, where we figure out net LX and net L, and we figure out whether which and which is by subtracting the deposits and borrows, which we get. So there was like a missed condition or like a missed case where we were just calculating if the net LX was positive, then we were as, and if it was negative we were treating, and we were just like throwing it in the rest of the scenarios on the else case. So what I also worked on was to, this is the updated logic, updated conditional logic which we had, which I added. was to consider on various other cases in terms of bad debt or over leveraged positions, or if there is any other scenarios where we return as like a null values or a zero value, which so that our front end caller function would take those and represent in a better way. So this kind of entire scenario came into picture when I was working on showing our LTV values on our front end, say on this. So this is our pool page where we also show the LTV values. So I'm pretty sure I might have shown this UI quite some time. So this is the value which goes, the wiring up the logic which goes underneath, which I just showed. Say, for example, we have some sort of a borrow, I have some sort of a borrow position and I have also have a deposit position. And if I withdraw all of my deposit position, we kind of show a high LTV value, or it's like a invalid, it's like a very, you cannot borrow or you cannot withdraw this amount because we have a borrow position. So the calculation or the math which goes behind the scenes of how do we do this is something which I fixed or worked on in the last week or so. So yeah, this is something which I focused, and obviously along with this, I was also working on the vaults stuff, which Johan mentioned. Gonna work together, me and Johan, on implementing the entire vault stuff. So yeah, this is like a brief update which I had. If we don't have any other questions, I'll just popcorn to Ishwar.
Thanks, Nathan. Yeah. So yeah, this sprint I continue to focus on. So we have a utility method for compute expecting a swap amount n. So what that means is, let's say if someone wants to swap USDC for ETH in our protocol, and let's say they want 1 ETH, so we have a helper utility method which will like give you, you need to put in 4,000 USDC, for example, right? And this utility method also takes care of the protocol fee for the swap, where we have a quadratic fee instead of constant, similar to Uniswap v2. So the reason behind having a quadratic fee which is dynamic is to have some price protection for the part of the lending part of the protocol that we have, so that there are no sudden price jumps. And if someone wants to manipulate the price of the pool by swapping large amount of like assets, then like there'll be, the fees will be like pretty much high. So that is the major reason to have this quadratic or like the dynamic fee that we introduced. And so as part of that, there is a fee formula that we use depending on where the reserves are, like what is the swap input amount and everything else considering. From this graph which will created initially, so this orange line is the kind of fee that we charge depending on where the reserves are. As you can see, there's a sudden drop here. So there are some weird edges like when we charge the fees. So let's say if the fee is moving back to the initial price, like we only charge minimum fee, which is this small orange line that you can see, it's very low percentage of fees that we charge. This is to be in favor of the protocol where the price is moving back towards where it started from. So that is the reason for this minimum fee. And yeah, like this is the quadratic fee that we have, and it gradually increases after this point depending on that. So there is a sudden drop here, this is one edge case, and there is a sudden jump here from where it transitions from minimum fee to the quadratic fee. Yeah, I was working with Will, pairing with him and trying to figure out how to handle these edge cases better, so that the fee output fee with the amounts that get calculated is smooth rather than this sudden drops or like sudden jumps that we see. So the unit tests were there to handle all these edge cases, but we also are looking to add more fuzz testing. So with fuzz testing, we can like control the params or just have wild range of params. Like example for the reserves or the pool price, like it can vary from 1:1 to 100,000. Like maybe like just taking the example of Bitcoin USDC for example. So yeah, with this fuzz test, like these parameters can be like have a dynamic range so that like we are testing all the edge cases and check for the accuracy of like whether the math is right, whether the formulas are right for computing these swap amounts. So that's been most of my sprint. And apart from that, like there was some minor research and that we've done with for the liquidation bot. So once we are code complete and like before mainnet launch, we would need to have a liquidation bot that will watch out for the user positions, and if some position is getting close to a liquidation, we would automatically want to get those liquidated to protect the protocol, like user position going into a bad debt situation. So this would essentially be an open source, but like mostly we are trying to get the initial architecture. As part of it, we are also we've reached out to Reactive Network to have a collaboration with them. So we are trying to like get some collaboration there and like potentially use their protocol for the liquidation system. We are still figuring things out, so it's pretty early. But yeah, it's also something like that will be our next priority right after we move into audits. So yeah, that's pretty much from my end. Let me know if anyone has any questions in the chat. Like, happy to answer regarding anything. If not, I'll pop on to Eric.
Thanks, Ishmael. Last sprint, I've been taking to finalize the upgradable proxies as the added some tests to try to get better understanding and to try to cover as much secure as possible to try to cover many of the areas to see if I try to get more risk control on the proxy itself. So that's, and also work out the code size problems, which is came up again. That code size reached the cap, squeezed a couple hundred bytes on that branch, so it gets compiled. It's and yeah, so that's not much on the, and also worked on the task, picked on the use average tick for the leverage premium, which caused an issue on the, sorry, I'm trying to, oh yeah, the ticket that I picked up is the use average tick for the leverage premium. That's one they suspended some time on the, and now that ticket has been worked out. Also needed to add some tests to make it. Yeah, this is the test is kind of like too tricky in the part of another ticket, and to get the leverage liquidation premium with the when it's in the wide range, and which we're trying to test it to see if the achieve a liquidation that's from good debt to a bad debt. That's I'm still trying to understand that ticket. I think that's about me for the last sprint. Sorry, I wasn't prepared to good for this time. Guess that's pretty much for me.
Am I the only one left?
Yes.
Okay, let me share my screen really quick. So trying to think of the best way. I wrote a lot of things, a lot of math. I don't know if going through this is very helpful, but basically had to resolve some equations. Probably what's more helpful is this Desmos. These lines are, the x-axis is tick, and the y-axis is the loan to value, now scaled to 100. 60 right here, this blue line is when something hits 60% loan to value. So if I look at this point right here on this red line, it's basically when -9, this hits 60% loan to value. And in our system, there's 3 loan to values that are important: the 75, 60, 75, and 85. 75 is the most important because once a position has their loan exceeding 75, then it can be liquidated at a profit. At 60, it can be liquidated at a loss. And there's some important reasons for this, but basically, if your position is at 65% loan to value, somebody could liquidate you and repay your debt, but only would be able to reclaim 50% of the collateral in value for your debt. So you would actually benefit from this liquidation. All your debt would be paid off and only half of your collateral would be taken for that debt. So these are like the important points that in the system. And what you're seeing is like the schedule of as the tick moves, what a position's loan to value is. Now, another kind of important thing is we distribute large positions. They might need to be liquidated over time. So the over time, maybe not the right word, but over ticks. So maybe the liquidation starts at one tick and then has to go across multiple ticks. And so the reason on this left side there's 4 different curves is the blue curve is the entire position's loan to value. The red curve is like the first chunk of the position's loan to value. The black curve is the second chunk of the position's loan to value, and this second black curve is the third chunk of the loan to value. And so this can be liquidated in chunks. And I think the thing that maybe show that's important is that this red curve, if I zoom out, was actually what our current behavior was doing. And the reason this is bad is that we would take one chunk and then say, hey, here's the first chunk, but that first chunk was not solvent. And because it was not solvent, it would have this huge loan to value. So the loan would exceed the value. And because of that, our system would have given a huge premium. So this was like the bug, is like, this was the schedule for a partial liquidation, one chunk of the position. And so I have been spending the last 2 weeks trying to get this to be stable, like these chunks to make sense. And so the other thing that I think this is working, the other thing that I had to do is make sure that the system was adaptive. I don't know if this version is the right version. Let me see if. Some of this might not be ready. I did some work and I think I lost it, but so okay, yeah, this is the number I was looking for. Let me just make this. There we go. So depending on how much of the liquidation, so if the kind of break even point is when, where'd my slider go? I guess the not break even point, but the sort of balance position, that this chunk should happen. This all intersects. This is like basically the tick at which that first chunk is expected to hit 85% loan to value. So these curves on the left are in balance. They're all going to happen appropriately. But our system also allows for maybe a position maybe there's not available liquidity where the position should be liquidated. And so as we divvy up the risk in the saturation library, a lot of that saturation could end up in the first tranche rather than the last two tranches. So the red being the first, the black being the second, and this black being the third. Maybe I should make that like purple or something. It's purple being the third, and the blue being the aggregate of the position. And so if for some reason we needed more, we had less availability in the last two chunks furthest away from the price, and we put more saturation in the first tranche, then you would see that this system now would increase the timeline for the loan to value and how quickly it would go. And so the more we put in that first tranche, the faster it would get liquidated. And then the rest of it would get liquidated later. And the reason for that is that there's actually less saturation there. So the majority of the position needs to be liquidated in like the first tranche rather than the last two. There's a lot of math here, and I spent a lot of time getting these equations to make sense. And it's probably took me like about 2 weeks to really make sure I was solving for the right things. And so now that I have all this in Desmos, I'll be working to implement these changes so that we don't use this loan to value schedule will be a liability, but that we properly use these sort of recalculated loan to value schedules for partial liquidations. So that is all I got. And I think that's everybody. Yeah, I think that's everything. Hopefully we didn't lose everybody, but if you guys have questions, feel free to drop them in the chat. I can give a moment or two for any last minute questions. If we've thoroughly lost everybody, then we can start winding this down and call it good. And go and let everyone enjoy their holiday. So, got one person typing, so I'll give them a moment. No questions. Cool. All right. Thank you, everybody. Just a heads up. I know that there's a lot of people from the team that are taking time for the holidays. From an engineering standpoint, we're going to return to like normal operations on January 2nd. Some of us will still be working during this time, but so we won't actually probably have another review until like 2 weeks into January. Maybe we'll do another abbreviated sprint. I'll still have to figure that out with the team. So we have 2 short sprints with a break in the middle, but we might just return back to a longer sprint cycle after we pick up in January. With that, happy holidays to everybody. Thanks for dropping in, and come join in our next meeting, and always happy to answer questions in the general chat if people have them.
Happy holidays, everyone.
Take care.
Take care.
Hey guys, have a good day.
Happy holidays.
Thanks, Evan. Yeah.
See you guys. All right.